termination of transcription by chain cleavage and the addition of 3' poly A tails. As mentioned earlier, the 3' end of pre-mRNA transcript is also modified. The 3' ends of RNA transcripts synthesized by the enzyme RNA polymerase II is produced by endonucleolytic cleavage of the primary transcripts rather than by the transcription termination. The actual termination of transcription events often occur at multiple sites that are located to 1000 to 2000 nucleotides downstream from the site that will become the 3' end of the mature mRNA transcript. That means transcription proceeds beyond the site that will become the 3' terminus, and the distal segment is removed by endonucleolytic cleavage. The cleavage event that produces the 3' end of an mRNA transcript usually occurs at a site 11 to 30 nucleotides downstream from a conserved sequence, consensus AAU AAA, located near the end of the transcription unit. Cleavage does not occur if this or a segment of some 20 nucleotides on its 3' side is deleted. The presence of the internal consensus sequences AAU AAA in some mature mRNAs indicates that consensus sequence AAU AAA is only part of the cleavage signal. Its context is also important. After cleavage by the endonuclease, a poly A polymerase enzyme adds about 250 adenylate residues to the 3' ends of the mRNA transcript. The addition of poly A tails to eukaryotic mRNAs is called polyadenylation. ATP is the donor in this reaction. The formation of poly A tail on mRNA transcripts requires a specificity component that recognizes the AAU AAA consensus sequences in RNAs, binds to them, and directs both the cleavage and the polyadenylation reactions. The specificity component, the endonuclease and the poly A polymerase enzyme are present in a multimeric protein complex that catalyzes both cleavage and polyadenylation in tightly coupled reactions. In contrast to RNA polymerase II, both RNA polymerase I and polymerase III respond to discrete termination signals. RNA polymerase enzyme 1 terminate transcription response to an 18 nucleotide long sequence that is recognized by an associated terminator protein. RNA polymerase III responds to a terminator in E. coli. The role of the poly A tail is still not firmly established. However, evidence that it enhances the stability and translation efficiency of mRNA is accumulating. It also plays an important role in their transport from the nucleus to the cytoplasm. Blocking the synthesis of poly A tail by exposure to 3' deoxyadenosine, that is codisepine, does not interfere with the synthesis of the primary transcript. mRNA devoid of a poly A tail can be transported out of the nucleus. The half-life of an mRNA molecule may also be determined in part by the rate of degradation of its poly A tail. An mRNA molecule devoid of a poly A tail is usually a much effective template for protein synthesis than is one with a poly A tail.